Have you ever wanted to run massive state-of-the-art AI models locally, but stopped because you don't have a massive GPU setup? What if I told you that you could run a 70 billion parameter large language model on a single everyday 4 gigabyte GPU? Or even run the massive 405 billion parameter Llama 3.1 model on just 8 gigabytes of VRAM? Today, we are talking about a game-changing open source project called AirLLM that makes exactly this possible. AirLLM is an incredibly popular GitHub project boasting over 13,000 stars that optimizes inference memory usage. Normally, running a 70 billion parameter model requires expensive hardware, but AirLLM lets you do it on a 4 gigabytes GPU without relying on traditional methods like quantization, distillation, or pruning. It achieves this by decomposing the original model and saving it layer by layer, loading it from your disk during inference. But that is just the tip of the iceberg. AirLLM has been constantly updated and now supports a massive roster of top-tier models, including native support for Llama 3, Qwen 2.5, Mixtral, ChatGLM, Qwen, Mistral, and InternLM. You do not even have to specify the model class anymore. AirLLM includes an auto model feature that automatically detects the model type for you. If you are a Mac user, you are in luck because AirLLM fully supports macOS running on Apple Silicon. And recently, they even added support for CPU inference and non-sharded models, making it more accessible than ever. Now, you might be thinking that loading from a disk layer by layer sounds slow, since disk loading is the main bottleneck. AirLLM tackles this brilliantly. First, they introduce prefetching, which overlaps the model loading with the actual computation, giving you an immediate 10% speed improvement. But the real magic is their block-wise model compression. By installing the bits and bytes library and enabling 4-bit or 8-bit compression when you initialize your model, you can speed up inference by up to 3 times with almost ignorable loss in accuracy. Because the bottleneck is disk loading, AirLLM only needs to quantize the weights portion to make the model loading size smaller, making it much easier to maintain accuracy compared to standard quantization that compresses both weights and activations. Getting started is incredibly easy. Just open your terminal and type pip install AirLLM. In your Python code, you simply import AutoModel from AirLLM, pass in the Hugging Face repository ID or a local path, and run your inference exactly like you would with a regular transformer model. You can even pass your Hugging Face API token directly in the configuration if you are downloading gated models. There are a few configurations you will want to know about to get the most out of it. If you are running low on storage space, you can set the delete original configuration to true. This deletes the original downloaded Hugging Face model and only keeps the transformed version, saving you half the disk space. Speaking of disk space, because the process of splitting the model is very disk consuming, the most common error users run into is a metadata incomplete buffer error. If you see this, it just means you ran out of disk space. So you will need to extend your space, clear your Hugging Face cache, and rerun. Also, if you get an error about asking to pad but the tokenizer does not have a padding token, just set padding to false in your tokenizer configuration. Lastly, if you see an empty sequence error, make sure you are using auto model instead of the older class names for models like Qwen or ChatGLM. AirLLM is completely redefining what is possible on low-end commodity computers, and it is available under an Apache 2 open source license. So clear out some disk space, install the package, and start running massive language models on your basic GPU today. That wraps up today's look at AirLLM. It is truly incredible that we can now run massive 70 billion or even 405 billion parameter models on everyday hardware. If you want to try it out for yourself, I'll leave the link to their GitHub repository in the description below. What massive model are you going to run first on your machine? Let me know down in the comments. If you found this video helpful, please drop a like, hit that subscribe button, and turn on notifications so you never miss out on the latest AI tools and tutorials. Thanks for watching, and I'll see you in the next one.